There are lots of things all around us, exciting things that surround us.
But how does it work?
Do you know?
How is it made?
Do you know? Things that go up, things that go down, things that go pop, things that go round, with special cameras to show you inside. It's going to be a big surprise.
But how does it work?
Do you know?
How is it made?
Do you know? Do you know?
Let's find out!
Hello, I'm Maddie. Today I've got some things I want to recycle, so I've come to the recycling bins. There are lots of things we can recycle, like these old plastic bottles, paper and cardboard, and glass, like this glass jar that had jam in it. But what happens to glass when it's been put in the glass recycling? And how does an old jam jar get turned into something new? Do you know how glass recycling works? Let's find out. How does it work?
Glass recycling.
To find out how glass recycling works, I've come here to a gigantic glass recycling factory. Glass is collected from recycling bins by big lorries like this one here, and it's all dropped off here at the yard. Listen to all the glass falling out of the recycling lorries. In the yard, there are 3 huge storage bays. 1, 2, 3. And together, they can hold around 3,000 tons of glass. That's the same weight as 157 double-decker buses. The glass is picked up from the storage bays by big diggers. Isn't that amazing? The digger tips the glass into that giant bin. It's called a hopper. There it goes! The hopper is connected to a conveyor belt. Not everything that arrives at the glass recycling factory is glass. There are other things that get muddled up with the glass too, like metal, plastic, stone, dirt and rubbish. We call these things contaminants, and it's the job of the glass recycling factory to separate the contaminants from the glass. Let's find out how they do it. This is called a screen. Can you see it's made of lots of metal rods with gaps in between? And it works a bit like a sieve. When it jiggles around, all of the small pieces fall through onto a conveyor belt below. And the big bits keep on going down that chute. All of the big bits drop into this machine. It's called a crusher. And inside, everything is crushed, so it's the same size as the smaller pieces. All the glass and contaminants come back together. Can you see that some of the small pieces are bouncing around? This makes all the pieces move along to the next machine. This is called an extractor, and it works like a vacuum cleaner and sucks away any of those light contaminants. But it's pretty tricky to see, so I think we should film it with one of my special cameras. This camera films in slow motion, which means we can film something that happens quickly, but watch it back slowly. Whoa! And look! All of the light contaminants, like little pieces of plastic, are being sucked away, leaving the glass behind. The glass doesn't get sucked up by the extractor because it's heavier and it continues on its journey. Now the glass is almost clean of contaminants. There's just some little bits of stone, brick and ceramic. Things like kitchen plates and mugs to get rid of. This is an optical sorting machine, and it gets rid of stone, brick and ceramic using its own special camera. But to find out how it works, I think we need to take a closer look.
Glass and contaminants move along a conveyor belt into the optical sorting machine. A light hits the conveyor belt so the camera can see the object. The camera takes a picture of the object and sends it to a computer. The computer can tell the size and colour of the object and whether it's glass. When the computer finds a contaminant, like stone, it sends a signal to an air jet inside the machine to blast it away. Now all that's left is the glass. Another optical sorting machine separates the glass into different colours. First, the computer looks for green glass, then sends a message to the air jets to blast it into the green bin. Once the green glass is gone, another optical sorting machine finds clear glass, called flint, and blasts it into the clear bin, leaving just the brown glass called amber.
Wow, that was so interesting. Here's all the green glass that's been separated. It's like a waterfall.
Look, there's all the amber glass. And the clear glass too. It's called flint.
Now the glass has been cleaned and sorted, it's ready to be used again and made into something new, like a jam jar. I loved finding out about how glass recycling works. What was your favourite part?
Do you remember the name of the machine that uses light to find things that aren't glass? That's right, it's called an optical sorting machine. Did you hear the sound of the glass as it was tipped out of the big recycling bin? Did you see how the extractor sucked all the light contaminants off the conveyor belt on the special camera? We use recycled glass in lots of different ways to make lots of different things, like glass jars. You can store lots in a glass jar, like honey, pickles, cookies, or as a special treat, you might have jam. Jam comes in lots of different flavours. Do you have a favourite? Mine is strawberry. Strawberry jam is made from strawberries. But how do strawberries or other fruit like blackberries or raspberries get turned into a thick jam you can spread on toast? Do you know how jam's made? Let's find out. How is it made?
Jam.
To find out how jam's made, I've come here to a jam factory. Today they're making raspberry jam. Today we're making one batch of raspberry jam, and that's about 160 jars, so we're going to need a lot of raspberries.
To make the jam, we also need sugar and lots of lemons. This is James, and it's his job to make the jam. James starts by weighing the lemons.
After the lemons are weighed, they're cut in half and squeezed to get all of the juice out, and I've been given special permission to help. So let's have a go at using this juicer. Thank you. Right, ready? Wow! The machine spins round and round, and look, can you see all of the juice flowing out of the spout here at the bottom? Lemons are really sour, and that's because they have something in them called citric acid. And it's the citric acid that gives them the sour taste. And nothing is wasted because we're going to use the lemon peel too.
Next, James weighs out the raspberries. Here, they use frozen raspberries. He also weighs out the sugar.
And now it's the fun part. We're going to heat everything up inside this, a boiling pan. Looks like a giant cake mixer, doesn't it?
At the moment, the boiling pan is switched off. First, into the boiling pan goes the raspberries.
That's a great splattering sound, isn't it?
Next, the lemon juice and the lemon peel.
The lemon peel
is really important because it's got something special in it called pectin. And when pectin heats up and mixes with the water from the frozen raspberries and the citric acid from the lemon juice, it acts a bit like a fishing net or a web, helping to catch the other ingredients. And it's what makes the mixture thick and sticky. It takes about 15 minutes for the jam to cook, so I've set up one of my special cameras to film everything. That way we can watch it back and speed everything up. Now you should never go close to a hot pan, but I've got special permission to show you what happens to our jam. Can you see the ingredients spinning round and round and mixing together? Now the sugar is added. And look, the jam is starting to cook. The boiling pan heats the ingredients to 100 degrees. That's really, really hot. The jam mixture still looks watery and runny, doesn't it? So how does it get thick and gooey like jam? Well, the water inside the jam mixture is heated up by the boiling pan and it turns into water vapour or steam. We call this evaporation. Evaporating and the steam is misting up our camera. As the water evaporates, the jam starts to get thicker. All there is to do now is take out the lemon peel. The jam's nearly ready, but to test to find out if it's thick enough, I've got to do something called the plate test. So there's a blob of jam on the plate and it's cooled down. And if it's the right thickness, it should make little lines called wrinkles when I push it. Should we find out? Okay, let's see. Oh, there you go. Lots of little wrinkles. So this is ready. Do you know what's making those wrinkles? It's the special chemical we find in the lemon peel called pectin. The jam is ready, so it's time to put it into jam jars. The jam is poured into here. It's called a hopper. The hopper is cone-shaped, so the jam will go to the bottom and then flow through the tubes to this machine called a depositor. And its job is to fill the jam jars. And just the right amount comes out each time to fill one jar. The lids are put on the jam jars when the jam and the air around the jam is still hot. But as everything cools down, it shrinks. And that leaves space inside the jar. So when we undo the lid, air can rush in, and this makes the jam jar pop up, and it sounds great. Listen to this. That sounds really good, doesn't it? I loved finding out how raspberry jam's made. What was your favourite bit? Do you remember the name of the special chemical that makes the jam thick? That's right, it's called pectin. Did you hear the sound the raspberries made as they tipped into the boiling pan? And did you see the ingredients being mixed together on my special camera? So the next time you have jam as a special treat, you'll know how it's made. And when you see a glass jar, you'll know how lots and lots of glass has been recycled to make it. I'll see you next time. Hello, I'm Maddie, and today I'm going for a trip on a sailing boat. Look, there's one over there. The sailing boat is floating on the lake. There are lots of things that can float on water, like a big colourful beach ball, and even ducks. But not everything floats. Some things, like this pebble, sink. So why does a big boat with people in it float when a small pebble sinks? Do you know why a boat floats? Let's find out. How does it work?
Floating.
To find out how floating works, I've come to a boating lake. This is Livy.
Libby, and it's Libby's job to sail boats here at the boating lake. She's called the helm.
And to sail the boats, Libby uses this, the mainsail. This is what the wind pushes to make the boat move.
It looks a bit like a giant bedsheet, doesn't it? The mainsail helps to catch the wind and sail the boat along. The body of the boat is called the hull.
And look, can you see the hull is wide and flat?
And the shape is really important for helping the boat to float along. Let's find out how. I've got a piece of modelling clay. I'm going to shape it into something that looks a bit like the hull of a sailing boat. A bit like this. I'm going to place this bit of modelling clay in a bowl of water. Let's see what happens. It floats. Now, I've got the same amount of modelling clay here, but this time it's rolled up into a ball. What do you think will happen when I drop this into the water? Let's find out. It sinks. But what makes the modelling clay float or sink? Well, it's all down to something called density. Density is how much space something takes up and how much it weighs, how heavy it is. When the modelling clay is shaped like this, it takes up more space than when it's rolled into a ball.
So that means when it's dropped in the water, it floats because it has a low density. But when the same clay is shaped like a ball, it sinks because it takes up less space and has a high density.
But how else does the shape of a boat help it to float? Let's take a closer look.
When a boat goes into water, the hull sinks a little and pushes water out of the way. This is called displacement. When water is displaced, it tries to go back to where it was, and this pushes the boat up. We call this force buoyancy. The more water the boat displaces, the more buoyant it is. Everything on Earth is pushed down by a force called gravity. But when buoyancy pushing the boat up is the same as gravity pushing the boat down, the boat floats.
That was really interesting. To show you how displacement works, I'm going to put some ice cubes in the glass of water.
And I'm drawing a line on the glass to mark the water level.
But all of this is going to happen really quickly, so I'm going to film it using my special slow motion camera. Okay, the camera is ready. Let's drop in some ice. Did you hear the splashing sound as the ice dropped in? It did happen quite fast though, didn't it? So let's look at the footage on my slow motion camera.
As the ice cube goes in, gravity pulls it down. Then the ice cube starts to float.
That's because the ice cube has displaced the water.
And can you see the displaced water has made the water level go up? It's now above the black line.
I think we should see floating in action for ourselves by setting sail. Now, you should never play near water without a grown-up, but I've got special permission to go onto the boat.
Do you remember that the shape of the hull helps to displace water and let the boat float?
Well, most of the hull is hidden under the water. So I've asked one of the crew to attach my special underwater camera to the hull so we can see what's happening underwater.
Look at the wide, curved hull of the boat. That's the part the displaced water pushes up against to make the boat buoyant. And look, on this special camera attached to the top of the main sail, you can see the water being displaced.
This is floating in action! I love finding out how a boat floats. What was your favourite part?
Can you remember what we call the boat when it's floating on the water? That's right, we say it's buoyant. Can you remember the sound the ice cube made when I dropped it in the glass? And on my special camera, do you remember seeing the hull of the boat as we floated on the lake?
Have you ever been to the seaside? Out at sea, there are boats, and on land, there might be a beach. I like wiggling my toes in the sand. I like to draw pictures in the sand. And I love making sandcastles. It's really fun, isn't it? But where does the sand come from? Do you know how sand is made? Let's find out. How is it made?
Sand.
To find out how sand is made, I've come to a beach. There's lots of different types of sand, and that's because sand is made of different things. White sand is sometimes made of coral, which lives in the sea. And black sand is made from lava that came from an erupting volcano. But the sand on this beach mostly comes from those cliffs. But how do these huge browny yellow cliffs turn into tiny grains of sand? To find out, we need to get up there. It's really high up on the cliff. You must never walk close to the edge without a grown-up. It's quite windy up here. Wind has an important job in making sand. Wind carries tiny, tiny pieces of rock in it, and when it blows against the cliffs, they wear the rock down a little. You can't see these tiny pieces of rock in the wind, but you can see how they made this rock bumpy. Over time, the bigger rock is broken down into smaller pieces. This is called weathering. But it's not just the wind that causes weathering. Even the sun weathers the rock. Can you see all of the cracks in the path? The ground has been baked by the heat from the sun, which has made it dry and shrink. We call this contracting. And rainwater can also weather the rocks when it falls from the sky into these cracks. In the winter, when it gets cold and frosty, the rainwater freezes and it gets bigger. We say that it expands. But when the water expands, it breaks the rock a little bit. It takes a long time for weathering to happen, but whenever it's warm enough for the ice to melt and cold enough for the water to freeze, the rock breaks a little bit and, eventually, the rock breaks apart. But what's happening at the bottom of the cliff, by the sea? Can you see the water is quite far away from the cliffs at the moment? The seawater actually comes in and out at different times of the day, every day. We call this the tide. And look, on this beach, we can see the tide moving. When the water is far away from the land, we say the tide is out. But when it gets close, we say the tide is in. We can hear the water moving in and out, can't we? When the tide moves all the way in, the seawater will crash against the rocks. Look, the tide is getting really close to the cliffs now. It wears them down a little bit every day. This is called weathering too. When rocks are weathered into small pieces, the small pieces are carried away by wind or water. This is called erosion. And to show you how erosion works, I'm going to use this box filled with sand. The sand has been shaped to look a little bit like the cliffs on this beach. What do you think will happen when I blow the top of the sand with a paper straw? That's right, some of it is blown off the pile. That's the same as the small pieces of rock being moved by the wind. This is erosion. Next, I'm adding some water to the box. This is going to be our sea, and I'm using a piece of card to make the tide. Oh, look at that! It's moving the loose sand at the bottom of our cliff and it's carrying it away. That's erosion too. Over time, weathering and erosion turns the rock into tiny grains of sand. And millions of these tiny grains of sand make a beach. So we know that sand is made from weathered and eroded rock. But do you know what rock is made of?
Rock is made up of lots of different natural materials called minerals. Lots of sand is made of a mineral called quartz. In fact, almost all the sand on this beach is made from quartz. But the quartz in this sand is tiny. So to see it a little bit better, you need to go and find a very special camera. Today, I'm going to be using a microscope camera. A microscope helps us to see tiny things by making them look much bigger. And the microscope is connected to this screen, so we'll be able to see anything we put under it. Whoa, that is brilliant. But I can zoom in even further. Watch this. Look, can you see the tiny white and shiny yellowish crystals? That's the quartz. I can't believe how much quartz there is in just a small bit of sand. And can you see the green mineral here? That's called glauconite. Isn't it beautiful? I loved learning how sand is made. What was your favourite part? Do you remember what it's called when the big pieces of rock are broken into smaller pieces by wind and water? That's right, it's called weathering. Do you remember the sound the water made when we were on the beach? And did you see the quartz in the sand under the special microscope camera? So the next time you build a sand castle on a beach, you'll know how the sand you used to build it was made. And the next time you see a boat out on the water, you'll know how it uses displacement to float. I'll see you next time.
There are lots of things all around us, exciting